Good morning. Here we go. Algebra 6.7, graph linear inequalities in two variables. You've been doing a lot of graphing of lines when it's an equal sign. Now we're going to do it with inequalities. It's not too bad. It's pretty similar. So the first thing that you should do always is just pause the video and practice this warm-up, especially since it's been a few days, maybe since you've thought about math. So go for it. Okay, this is what you should have gotten. And it says, tell whether the ordered pair is a solution of the equation. Well, it has to make the equation true to be a solution, or to tell you that this point is on this line. So I just plugged in x and y to see if the left side does equal the right side. Same with here. I plugged in x and y to see if the left side equals the right side, and it does. So this point is a solution. This point is not. Basically, it tells me that this point is not on this line, and this point is on this line. Graph the equation. Notice that it's in standard form. X and y are on the same side. When it's in standard form, it's the easiest, most efficient way is to do a baby table. So I'm going to go ahead and just graph that right there. So here we go. That's what I did. Okay? Tell whether the ordered pair is a solution of negative x plus 2y. This is the same thing. It's just saying, well, does this ordered pair make this inequality true? So I'm going to plug it in. Okay, so negative 0, which there really isn't such a thing, but let's just see what happens here, is less than 8. Is this a true statement? That's a question mark, by the way. Okay, so negative 0 plus 0, is that less than 8? Is 0 less than 8? Yes. So this point is a solution to the inequality. Okay, do it again. So negative 0 plus 2 times 4, is that less than 8? Okay, so this is 8 is less than 8. Wait a minute, that's not a true statement. So no, this point is not a solution to this inequality. It doesn't make it true. Okay, let's try this last one. Negative 3 plus 2 times 5, is that less than 8? So negative 3 plus 10, is that less than 8? Negative 3 plus 10 is 7, and that is less than 8. So yes, this point is a solution to this inequality. So what you're doing when you're graphing linear inequalities is you're going to represent all the points that make that inequality true, all the solutions. So it's pretty much the same thing. We just got to add one more step, that's shading. So here's one thing you got to remember that's slightly different. When you have a less than or a greater than, less than or equal to or greater than or equal to, you're going to draw your line with a solid line. That's because all the points on the line make that inequality true. If it's just less than or greater than, you're going to use a dashed line. That means that the points on the line itself don't make that inequality true. But I'll show you. Let's keep going. First of all, we're going to graph this. So really, you just, notice it's in slope-intercept form, so you just have to graph 2 points. So it might be easier just to make the line to write it as an equals. And you know that this is the y-intercept and this is the slope. So I'm going to start at point 1 on the y-axis. I'm going to use the slope to get my second point. So I go up 3 over 1. Before I connect them though, I have to look at this. Is this going to be solid or dashed? So right here I told you if it's got the equals underneath, it's a solid line. So I do connect them with a solid line. Okay? So I have the line. Remember, I'm trying to represent all the points on this graph that will make this inequality true. All right. The last thing you have to do is what we call shading. Because there's going to be a whole bunch of points other than just what's here on the line that are going to make this inequality true. So to decide what side to shade, you have to test with the ordered pair 0, 0. So I'm going to plug in the x and the y from this point, x and y, into my inequality and see if it makes it true. So is 0 greater than or equal to 3 times 0 plus 1? Is 0 greater than or equal to, this is 0 plus 1, well that's just 1. Is this a true statement? It's not true. So I shade the side without 0, 0. Okay, so that means I have to shade this side. Because 0, 0 is not a solution, so it's not part of the solution set. So you shade the other side. Now what this tells me is I can pick any ordered pair from over here, any of these ordered pairs, anything on the line and anything in the shaded area, plug it into my inequality, and it would make that inequality true. It would be a solution, just like we checked with these points up here. Okay? So that's what you're doing when you graph inequalities. Let's try another one. The first thing you do is graph 2 points. So if it helps, write it with an equals just to get your 2 points. Now this is in standard form. So I'm going to make a little baby table. 0 for y, 0 for x. 4 times 0 is 0. That goes away. So my x is negative 8. Plug in 0 for x. Cover that up. Divide both sides by 4. Y would be negative 2. Now I have 2 points that I can graph. So I'm going to go over negative 8, up 0, over 0, down 2. Okay, now, but before I draw my line, I have to take a look. This is just a less than, so that means I have to use a dashed line. So I'm going to connect them with sort of like a dashed line like this, not a solid line. This tells me that none of the points on this line are solutions to that. Okay? Now I still have to decide what to shade. So I'm still going to test with 0, 0. Remember, this is x and this is y. Okay? So I'm going to plug it into my inequality, substitute 0 for x and 0 for y, and see if that is a true inequality. 0 plus 0, is that less than negative 8? Be careful, people want to say yes, but it's not if you think of the number line. 0 is bigger than negative 8. Okay, so this is a true statement. So I have to shade the side that has 0, 0, because 0, 0 is a solution. So I'm going to shade that. Now this tells me that any single point up here is going to make that inequality true. You're graphing all the solutions for that inequality. Okay? So turn it over. Let's do some more. All right, so here, notice that it's in standard form. So if I just write it like this, just to get my 2 points. Remember, I only need 2 points so I can get this line. I'm going to plug in 0 for y and 0 for x. If I plug in 0 for y, that's going to go away. My x is negative 1. There's 1 point, negative 1, 0. If I plug in 0 for x, I got to divide both sides by 3, which will give me negative 1/3, and that's okay. I can have a fraction. So I'm going to plot these 2 points, negative 1, 0, and 0, negative 1/3. So it's just kind of like 1/3 of the way between these two. Okay, now I have to notice that this is going to be a solid line because it's got the equal underneath. So that means it includes all the points on that line. That's what the solid line represents to me. Okay, then I got to decide what side to shade. Easiest point is to use 0, 0. Now sometimes your line might go through 0, 0, and then you can't use it to test with. You can just pick a different point. Like you could pick 1, 2, or negative 1, negative 1. It doesn't matter. Okay? But let's test with 0, 0 here. 0 plus 3 times 0 is greater than or equal to negative 1. Let's see if that's a true statement. Is 0 greater than or equal to negative 1? Remember, just like the other side, it's tempting to say, no, that's not true, but it is true because 0 is bigger than -1 on the number line. So that means I shade the side that has 0, 0. This tells me that every single point here and on the line would make that inequality true. Okay? All right. Oh, look, these look a little different, but you know how to graph these lines. Okay, if I write it like this, y equals 1, this is a line, and it tells you that all the y coordinates are 1. And if you can't remember what that line looks like, you can make a little table, make all the y coordinates 1, pick anything for x, doesn't matter, plot those points, over 0, up 1, -1, up 1, over 2, up 1. Remember, this is a horizontal line where all the y coordinates are 1. Now, go back and notice that you have to use a dashed line. So I'm going to connect those with a dashed line. Now, there's a couple ways to look at this. This is telling you that all the y coordinates for this inequality are less than 1. Well, here is where y equals 1. So that just means I got to shade everything below, because this is where all the y coordinates are less than 1. If you just simply can't remember that, you can still test with 0, 0. Know that you're just going to use the y coordinate, because that's all that's here. So say to yourself, okay, is 0 less than 1? Yes. So I shade the side that has 0, 0 on it. All right. Oh, here's one that's x equals 2. Remember, this is a line. And it's where all the x coordinates are 2. So if I go over here to where this x coordinate is 2, every single point here has an x coordinate of 2. Over 2, up 2, over 2, up 3, over 2, down 2, over 2, down 3, all of these. So that means it's a vertical line where all the x coordinates are 2. Then you go back and say, okay, I got to use a solid line because it's got the equals underneath. So I'm going to connect it with a solid line. This is telling me that all the x coordinates are greater than 2. So if you think of the x-axis, this is the side that has all the x coordinates greater than 2. So I got to shade that side. If you just can't remember that, just say, okay, I'm going to test with 0, 0 again. Except I'm only going to use the x coordinate because that's all I have here. Is 0 greater than or equal to 2? No. So this is not a solution. So you shade that side. Okay? That's all.